Hello, I'm Jenny Lynch, and this is the Creative Science Podcast.
Hi, I'm Matilda, and today's show is all about the force of gravity.
We will be exploring the freaky force of gravity with lots of groovy gravity facts, a deep dive into centre of gravity and astronomical orbits, a question about black holes, the past, present and future of gravitational science, and a gravity-defying trick for you to try yourself at home. Let's get down to business with 5 fun and fascinating fast facts about forces.
Fact number 1. A force is a push or a pull.
A force can make something start moving or stop moving. It can make something go faster or slower or change direction, or it can make something stay exactly where it is. What are you doing right now? If you're sitting in a chair, the force of gravity is pulling you down towards the floor, but the force of gravity is balanced by the force of the chair pushing back up, so you stay where you are and hopefully don't fall down to the floor.
Fact number 2. Gravity is a non-contact force because it can work at a distance.
You don't have to be touching the ground to feel the force of gravity. You might have experienced this for yourself if you've ever fallen out of a tree.
Fact number 3. Earth's gravity is what keeps you on the ground and stops you floating off into outer space.
Gravity is pulling down on all parts of your body all the time. The Earth has a lot of mass, so you feel a strong pull from the Earth's gravity. Your body has gravity too. It's pulling back on the Earth, but because the Earth is so much more massive than your body, you experience a pull towards the Earth and not the other way around.
Fact number 4. Earth and the other planets in the solar system orbit the Sun, and they are held in their orbits by the gravitational pull of the Sun.
The Sun is a lot bigger than any of the planets, just like Earth is a lot bigger than your body. The planets don't fall down and crash into the Sun because they are moving very, very quickly. The Sun's gravity keeps the planets in their huge orbits and stops them flying away.
Fact number 5. There are billions of stars in the universe that are bigger than the Sun, and these stars have a lot of gravitational pull.
A black hole is formed when a massive star explodes and then collapses back in on itself. The gravitational pull of a black hole is so strong that nothing can escape once it has fallen into a black hole.
Let's take a deep dive into the center of gravity and astronomical orbits.
The Earth's gravity is pulling down on every part of your body all the time, but scientists sometimes like to imagine that gravity is pulling down on just one point in your body. This point is called the center of gravity. The center of gravity is just the middle of all your weight. To find your center of gravity, start by standing up straight. Next, point one of your pointer fingers in from the side of your waist. Take your other pointer finger from your other hand and point it at your belly button. Now picture 2 imaginary lines pointing through the middle of your body, one from the side and one straight through your belly button. Where these 2 lines meet is roughly the position of your center of gravity when you're standing up.
Why do scientists care so much about the center of gravity?
It's very useful to know where the center of gravity is to make sure it is supported against the force of gravity. When you're standing up straight, your center of gravity is supported by your body and it is held up by your legs and your feet. As long as your center of gravity is supported by your legs and feet, you should be quite stable and you won't fall over. What if you keep your feet on the ground and lean forwards? Does your center of gravity stay above your feet? If your center of gravity moves too far forwards, it won't be supported anymore and you'll fall over. Usually, a person will naturally stick out their bottom when they bend forwards. This makes sure their center of gravity stays over their feet and it's supported against the force of gravity. Scientists often use the center of gravity of a star or a planet when they're doing calculations about gravity or orbits in space. This could be the planets orbiting the Sun, or even how the solar system orbits around inside the Milky Way galaxy.
The solar system is in the Milky Way galaxy, and the Sun is just one of 100 billion stars in the Milky Way. At the center of the Milky Way galaxy is a supermassive black hole. All of the stars and planets in the galaxy are orbiting around the supermassive black hole in a spiral shape.
In the universe, there are 2 trillion galaxies, each held together by the force of gravity, and each with a unique shape. The Milky Way is a spiral shape, but some galaxies are elliptical, which means they have an oval shape, or they might be lenticular, which means they're shaped a bit like a lentil. By classifying galaxies according to their shape, astrophysicists are learning more about how galaxies form.
Did you know that you can help to classify galaxies and help with real scientific research? A project called Galaxy Zoo has been running for over 10 years, and it invites volunteers to look at images of real galaxies. Volunteers are shown telescope images of galaxies, and they classify them according to their shape. To find out more and to volunteer to classify galaxies, search for Galaxy Zoo. Now it's time for a question. What would happen if I fell into a black hole?
To visit a black hole, you only need a one-way ticket, as there is no coming back. The gravity of a black hole is so immense that nothing can escape the gravitational pull, and the gravitational pull gets stronger the closer you get to the black hole. The event horizon is an imaginary boundary around a black hole, and this is the point of no return. If an object crosses the event horizon, there is no chance of escaping the black hole. If you did get close to a black hole, the pull of gravity from the black hole would increase so quickly that the pull on your feet might be more than the pull on your head, and the black hole could stretch you out like a long piece of spaghetti. A black hole is black because not even light can escape its gravitational pull. However, the area around a black hole is made up of glowing gases. As objects fall towards the black hole, they give off radiation, and astronomers can use this to take pictures of a black hole. The first image of the black hole at the center of the Milky Way was made in 2022. The black hole in the middle of the image is surrounded by a bright circle of glowing gas. The gravity of a black hole is so strong because it has a huge amount of mass in a tiny point in space. And as more objects fall into the black hole, the mass increases and the gravitational force becomes even stronger.
How do we know what we know about the force of gravity? Gravity was explained in the 1600s by Sir Isaac Newton after he wondered why an apple always falls straight down to the ground.
Newton worked out mathematical formulas to explain how gravity works, and his ideas are still being used today to explain most of the effects of gravity that we can see in our day-to-day lives. It's Newton's laws that most people learn about when they study gravity and motion in school. In the 1900s, Albert Einstein thought more about what might cause the force of gravity, and he concluded that massive objects bent the space around them, and that light can be bent by gravity. These ideas are not in our everyday experience, and most people don't learn much about these unless they study lots of science at high school or at university. Einstein's theory of relativity explained gravity in a completely new way, but even he wasn't convinced that his ideas would ever be proven. He predicted something called gravitational waves, and it wasn't until 2015 that these waves were detected for the first time, providing evidence to support Einstein's ideas about gravity. Scientists measured the gravitational waves from two black holes coming together in an enormous collision. Gravitational waves are incredibly small ripples through the universe, and after they were first imagined by Einstein over 100 years ago, measuring the waves for the first time was an incredible discovery about gravity. As I said earlier, the center of gravity of an object is the middle of all its weight. To stop something falling down to the ground, you need to make sure its center of gravity is supported.
You can test this out yourself. Of course, you should tell an adult what you are doing, and make sure you get their permission first. You will need modeling clay or playdough and an empty cardboard milk carton or any other long cardboard box. For example, a biscuit box.
Lay the box on its side on a table and slowly push the box so that one end of the box is off the edge of the table. Keep pushing the box until it only just stays on the edge of the table. Push a little bit more until the box falls off the table. Where is the center of gravity of the box? It's in the middle. As soon as the center of gravity moved past the edge of the table, it wasn't supported by the table anymore. The force of gravity took over and the box fell to the floor. Now you're going to change the position of the center of gravity in the box by adding some modeling clay or Play-Doh. Take a ball of clay or dough and squash it into one end of the box. Where's the center of gravity of the box now? It's moved towards the end of the box that has the clay or dough. Lay the box on its side on the table again and slowly push the box so the empty end of the box moves off the edge of the table. Keep pushing the box until it only just stays on the table. It will look like magic, like the box is defying gravity. Finally, use your gravity-defying box to impress your friends and family. After that amazing trick, it's time for us to disappear. Thanks for listening, and remember to stay curious.
The Creative Science podcast was recorded on the traditional lands of the Bidjigal people. For more information about Creative Science Australia, visit creativescience.com.au.